Welcome to Arcteq Webinar Wednesday. Topic of today is a case study in a paper mill where we achieved cost savings and lifetime extension for a very old switchgear by installing reusable quenching device. My name is Anjala. I'm the Managing Director, co-founder of Arcteq. This is a recording. We will be available in the chat tool during and after the presentation. You can find the questions and answer tool in Teams that you're using. If you prefer, you can enter your name in the chat. All right, let's get started. Here are some facts about the mills in question. This is a Stora Enso paper division plant in Anjala in Finland. Products coming out from the factory are folding boxboards, book paper, magazine paper, and enhanced newsprints. Main markets for the plant is in Europe. Total capacity for the production is 725,000 tons annually, and the annual turnover of a mill is about 450 million euros. Running on 500 employees, and as the whole Finland has a very long history in the pulp and paper business, so does this mill. This was founded in 1938. Here another picture of the mill in a nice sunset. Looks like a summer day in the midsummer. We're almost in the midsummer here in Finland. Nightless night, one good example of the picture here. And electrical distribution in the mills is consisting of 7 main transformers, each around 50 MVA, the 2 110 kV switching stations, and the medium voltage distribution is running in 10 kV and 6 kV levels. We have about 300 bays altogether in the mills. Active power consumption, which is bought from the grid, is about 140 megawatts. Just some details on the size of the operations we have in case. This particular switchgear upgrade project was a 6 kV lineup, and Arcteq's first acquittance in the plant was an installation of motor commander relays for protection and control of large synchronous motors. The first ones were installed back in 2016. This particular project was kicked off when another motor commander was due to be installed. And one of the motivators in the project was actually removal of the current limiter in the system. Current limiters do their job, limiting the fault currents, but side effects quite often involve power quality issues. So was the case here as well. Once the reactor was removed from the system, the withstand capacity of the circuit breakers was exceeded. Luckily here, the bus bar and disconnectors had still appropriate withstand ratings. This in turn gave 2 investment alternatives. One, retrofitting breakers and relays and improving the safety by installing the arc quenching device. Or another alternative considered by the customer was installing a totally new lineup of switchgear. Here a simplified principal single line of the switchgear, originally installed back in 1976. You can see one incoming feeder fed from another 6 kV switching station. We have several large motors on this lineup. So you see 3 synchronous motors of about 8 megawatt or 10,000 horsepower. You see 1 asynchronous motor, also large, almost 5 mega or 6,000 horsepower. And all these are refiners. Then also feeders to the distribution of the system. VT section actually became very useful and important in this part, since that actually was selected to be the final location for the arc quencher installed in the gear. Since these large motors were starting with the reactor in place, a voltage drop was quite considerable, and that was beyond acceptable limits, which again led to the need for removing the reactor from the system. And once this retrofit project was initiated, total evaluation of the system was then done. And if you look at the commercial evaluation, quite interesting topic always, and more than ever in these uncertain times, the priority of all the plants, not only pulp and paper mills, any factory today, is looking at maintaining the process on, keeping the production on. And here the question again is to find the right optimal cost-efficient solutions on keeping the plant going. So here, these figures that we will talk here are quite generic and ballpark figures, not exact scientific figures, but giving a good understanding of the comparison here. So we look at the equipment cost, direct equipment cost, installation cost, and the production cost. Here again, for the sake of round figures, we are using estimated figure of production 1,000 tons per day at sales price of 500 euros a ton. So this results in a daily production cost of 500,000 euros in this sort of a plant. Here in this slide, you see a comparison of commercial evaluation on these generic terms for either a retrofitting arc quencher and related equipment, or installing totally new switchgear lineup. First row on the equipment cost, a retrofit of quencher, protection relays, circuit breakers was resulting in about 75,000 euro equipment cost, and installation cost, direct labor cost, about 25,000 euros. Comparing this to the new switchgear layout, new equipment cost in excess of 200,000 euros and installation cost at least double to the retrofit activity. These figures alone, if you compare them to the plant's annual turnover, may not be significant on making the decisions. It's lots of money, but not maybe the significant factor. Then let's look at the outage time. In case of retrofit activity, all activity could be done in 4 days, which means that it's during the plant maintenance outage or shutdown. Whereas installing a new switchgear would take a couple of weeks. So this comes to the next row on extra outage cost. We can say in the retrofitting activity, the extra outage cost is 0, since it's done during the maintenance shutdown. If we calculate 10 days extra outage time for installing a new switchgear, with these round figures that we are using, you get to the value of 5 million euro cost for the outage time on installing the new switchgear. So jump of the total project cost can be very large. So total cost savings significantly on above 5 million euros. Here, let's look at the implementation, how the actual quenching device implementation was done. Here in this same simplified principle picture, you will see all the components needed in putting the arc quenching device in use. That's all you need. So we do have point sensors installed for the arc detection. So arc light detection is achieved by the point sensors included in each compartment to be protected. Here, quite open spaced metal enclosed type of switchgear. So practically 2 sensors per bay is enough. In the incoming feeder, we do have a current monitoring relay, since the protection principle is typically applied on 2 criteria, light and current. So dual tripping criteria is typically recommended in critical applications. Here, obviously, a very critical piece of switchgear, since any outage here would put the plant down. Then we have in the outgoing feeder bays, I/O extension units, you could call them, for accommodating enough arc sensors into the system. And the actual arc quenching device is bolted, as I already mentioned, in the VT section. And this always comes into the consideration of where you find the space, where it is most convenient to locate. And in this particular application, the VT section provided enough space for installing the arc quenching device. Some small curiosity here, you see the SS signs, SS0A, SS7, SS7. These are our standard arc scheme nominations. So all system is based on the standard arc schemes, library of pre-engineered solutions. Arcteq total scope of supply included in this case kind of a complete protection solution. So our scope had the quenching device and the AQ100 series arc flash protection relays, as shown in the previous slide. We included the motor commander already before the full retrofit activity, into 15 type of motor protection IEDs, and second phase of the project involved retrofitting of transformer protections, both 3-winding and 2-winding transformers. Circuit breakers were supplied by the others, and the installation was carried out by the customer, who in turn was trained by Arcteq engineers. So our scope of supply was equipment, training, and commissioning of the system. Quick look on different products supplied in a project. Starting from a motor production IEDs type AQ-M215. This is part of the AQ200 series production and control IEDs, which are the most accurate production relays in the world. For the motor protection, the frequency independent operation based on the patented measurement algorithm can be quite interesting, especially in case of frequency drives in use or soft starters. In this case, we had the direct started motors. Typical protection functions: motor, overcurrents, jams, thermal overloads, startup protection supervisions, under overvoltages, etc. Basic set of protection functions. AQ-M215 and all Arcteq motor relays provide a sophisticated thermal reading, thermal replica, with or without RTDs, with up to 7 time constant, or for simplicity, just a single time constant operation, user selectable. Interesting for many industrial applications, harmonic content in the system. So the high sampling rate in the 200 series relays allows us to record harmonics up to 31st. So on the disturbance recording, you may see, for instance, issues on the variable frequency drives causing harmonics, etc. This can be quite powerful analysis and Transformer protections, again applied in the second phase of the project, included the 2-winding and 3-winding transformers, typical protection functions, differential, overcurrent earth fault protections, and restricted earth fault. Here, like in all Arcteq products, ease of use is in a focus, and our free of charge setting and configuration tool includes also a transformer wizard, which makes setting of a transformer from the nameplate values easier than ever. Very useful tool. You can download it from our website. And then the actual arc flash protection implementation with the dedicated arc flash protection units, AQ110, AQ101 relays, and related arc flash point sensors. Here, notable is that all the arc flash protection was separated from the other protection system. So motor protections, feeder protections, transformer protections are set aside. They are on the numerical IEDs, but the most critical and sensitive protection, which is the arc flash protection, is implemented by dedicated arc flash protection relays. So these AQ100 series arc flash protection relays, along with their sensors, control the arc quenching device, and they do trip the circuit breakers as well. Having a dedicated relay provides reliability. System is based on the standard arc schemes, very easy to use relays, no setting software involved. Only one single push button operation. And for the sake of simplicity, very limited customer settings required. This is especially important since most of the nuisance trippings in the system, if any, are caused by wrong settings. Here with the AQ100 devices, which are controlling the arc quenching device, we have eliminated almost all the customer settings. And here the actual quenching device, AQ2000, for medium voltage up to 17.5 kV, based on Thomson coil. And this Thomson coil technology makes the unit resettable. Ratings up to 50 kiloamperes for half a second short circuit capacity. And so for the arc quenching device principle, we'll play here a short video describing the principle. Here we go.
The AQ1000 arc quenching device, the latest protection innovation from Arcteq, the pioneer of arc flash protection. Active arc quenching is the most exciting new solution for improving personal safety, maximizing asset reliability, and minimizing downtime. The AQ1000 can be applied to protect any system with up to 100 kiloampere and 690 volt rated equipment. The arc quenching device is bolted to the bus bars in the most practical location, typically close to the main circuit breaker. The AQ1000 adds to the well-proven AQ100 arc flash protection system. The AQ100 system senses the arc and initiates rapid arc quenching sequence, creating a controlled low-impedance path, transferring arc fault current to the quenching device. All this occurs in less than 4 milliseconds. Arcing faults often lead to catastrophic consequences. By maintaining the arc time in less than 4 milliseconds, the AQ1000 mitigates switchgear damages and minimizes the process downtime and may save human lives. The AQ1000 operation is based on patented and dependable Thomson coil technology. The bulletproof mechanism operating time is as little as 2 milliseconds. The use of Thompson coil technology makes the AQ1000 fully reusable and testable. The system can be conveniently reset after factory or site testing. Embedded electronics provide for full system self-supervision and operator status indications. The quenching device reusability and onboard supervision features raise the bar on system reliability to a new level, offering guaranteed peace of mind by the ultimate personal safety and return on investment in a single operation in plant lifetime. Less than 4 milliseconds arcing time keeps incident energy levels in less than 1.2 calories per centimeter squared, according to IEEE 1584. AQ1000 arc quenching device, tested and approved according to latest UL and IEC standards. Arcteq, the pioneer.
All right, we've seen how the quenching device operates. Here, actual pictures of the 6 kV switchgear after the retrofit activity. So the original switchgear is from 1970s. You can see door-mounted AQ100 series devices, AQ110P, AQ101, and then down on the line you see AQ-M250 and motor protection IED installed. Here, quite good close-up on our AQ101 and 110 units, and you see the LED panel for exact fault location information. This is quite critical, since if we would have an arc flash incident in this particular switchgear, where we have arc quenching device sitting, there is really very limited burn marks or any other information of the fault location in the switchgear, since the operation time is limited to less than 6 milliseconds. So these LED panels are very important. They will pinpoint you to the actual fault location based on which sensor found the fault. And the next picture here shows the actual arc quenching device installation. Again, it was in this particular switchgear possible to fit it in the VT compartment. Sometimes you have space in the incoming sections. Sometimes you may extend the bus bar to go to the next section or extra section for the AQ2000, but VT compartments are quite often spacey, so to say. So here you see the actual mechanical operation part of the AQ2000, which is actually closing the 3 phases for the arc transfer. And we have the AQ2000 trigger device, which is the electronics below that. So the electronics is controlling the mechanical part, and the electronic part itself is controlled by the relays. Let's move to the conclusions. So, with the mathematics that we did, the simplified mathematics in the beginning of the presentation, we calculated that this sort of retrofit activity compared to a new switchgear lineup can end up with up to €5 million savings. Installation and commissioning of the system was completed during the normal maintenance audits, 4 days. So installing the new circuit breakers, relays, and AQ2000 arc quenching device makes installation safe, and the switchgear lifetime is extended for next decades. On the safety aspect, if you look at the IEEE 1584 arc flash incident energy levels, arc quenching device keeps typically the values below 1.2 calories per centimeter squared. And I'll end up the presentation by the voice of the customer, Mr. Harri Mörsari, Engineering Manager in Stora Enso, set on selecting Arcteq equipment for the plant. We were impressed by the receptability of Arcteq arc quenching device. Thank you. So this concludes the webinar of today. Thank you for your attendance. We will be available in the questions and answer session in the chat tool. And next week webinar will be about the multifunctional alarm and indication unit, AQS254. We hope to see you there. Thank you, bye.